This video is about writing very small numbers in scientific notation. So by small numbers, I mean like micro. So if we take the number right here, okay, let's call that the length of Mr. Carlson's beard hairs. Okay, so we take this right now and we are thinking about how we can represent this in a way that is easier to write in that scientific notation format. Okay, well, I know that I need a mantissa, just like I do when I write really large numbers in scientific notation, and also I need to multiply it by a power of 10. Okay, and we need to think about, oopsies, we need to think about what the power is going to be here. So I have the number 3.2, but I need it to be smaller. So I know that in order to make the number 3.2 smaller, I can in fact divide by 10. When I take 3.2 and divide by 10, I get the number 0.32. Sorry, equals. Now, division, though, isn't going to help me right now, as is, get it to this format. But I know that division and multiplication are related to one another. Okay, so I know that dividing a number by 10 is also the same thing as taking that number, 3.2, and multiplying it by 1/10. I know that I get the same thing dividing by 10 or multiplying by 1/10. So now this is going to help me some because I can see that it is 1 over 10 to the first power. Okay, so if I continue with that and I look at 3.2 times 1 over 100, that's equal to that number right there. 3.2 times 1 over 1,000, that equals this number right here. 3.2 times 1 over 10,000. Oh man, these numbers are becoming a pain to write again. I'm almost there. Now I'm also starting to see a pattern here that 1/10 is the same as 1 times 10 to the power of 1. This is also the same as 1 times 10 squared. I know I can write 1,000 as 10 to the third, so I can rewrite this number here as 1 over 10 to the third. I can rewrite this number here as 1 over 10 to the fourth. And I'm almost back to my original one. So if I look at 3.2 times 1 over 100,000, then I finally get back to this value here, which is our original number up here. Okay, so that is 3.2 times 1 to the 3.2 times 1 over 10 to the fifth. All right, so I know that that is what I need to get in this format. So let me show you a little something about powers and how we can rewrite them. Okay, so if I have 10 to the fourth, I know that that number is equal to, it's equal to 10,000. 10 to the third is equal to 1,000. 10 squared is equal to 100. 10 to the first is equal to 10. So if I continue this pattern, I now get 10 to the 0. If, as you can see here, as I went up, I multiplied each by 10. As I'm going down, I'm dividing each by 10. divide by 10. Or, like we said, that's the same as multiplying by 1/10. So now 10 to the 0 power is actually 1. What would happen if I divided this by 10 or multiplied this by 1/10? Well, I would get 1/10 here. If you look at the pattern here, this exponent is continuing to decrease. So 1 over 10 is actually 10 to the negative 1 power. 1 over 100, which is the same as 1 over 10 to the second, is actually 10 to the negative 2nd power. So then, if I continue with this pattern, 10 to the negative 3rd power is equal to 1 over 10 to the 3rd power, which is the same as this number right here. Okay, so when I have 1 over 10 to the 5th power, in order to rewrite that as in scientific notation, the notation itself, I have 3.2 times 10 to the negative 5th power. I would continue with this pattern and see that I get a negative exponent in order to represent a number that is very small. So just one more time, I want to show you with the number, another example. This time we'll use 8.2 times 10 to the negative 3rd. Okay, so in this case, I can do all of these steps again, but I can also see here, let me go back and show you with 3.2 times 10 to the negative 5. If I had this number here to start with, 0.1234332, I can take my mantissa here. After all those zeros, I box off my first few numbers, and I estimate it to be a mantissa of 3.2. And I can see that my place values are getting smaller. So I know it's going to be times 10 to a negative power. Let's count the number of place values to help us here. 1, 2, 3, 4, 5 place values to get back to your original. You can see if we did it this way here, or if we looked at this here, we got the same answer of 3.2 times 10 to the negative 5th. So let's now look at 8.2 times 10 to the negative 3rd. I'm actually going to make this a little bit bigger because let's make it to the negative 6. So I'm going to rewrite my mantissa here of 8.2. I'm going to write it over here because I know my number is going to get smaller with those negative exponents. And I'm going to count my place values. 1, 2, 3, 4, 5, 6. And of course, I need zeros to hold those place values there. Excuse me. And this then is how I write my number. 8.2 times 10 to the negative 6. I write it just like this here. You can also put a 0 here. It doesn't matter because it's like saying 0.3 versus 0.3. These two are equivalent, so that would be equivalent there. You should put a 0 in the ones place for that. So that is how you write very small numbers in scientific notation.